Alright, welcome back to the channel where we build a video game from scratch using Love2d and Lua. Let's check out what we did yesterday. We've got this fire that's rotating around us. Now, it is going a bit too fast, but you can kind of see that it is animating there. So we're going to slow it down so we can get a better look at that, and then I'll tell you what the plan is for today. So let's just slow this down so it doesn't rotate as fast. Okay. Okay, so I'm kind of thinking, I wonder if we can leave this on screen. I guess, no, I'll show you what I'm trying to do. So I made this other project here. It's a very bare bones. Let's make a TMUX session so we can switch to it. It's called spinning. We'll call it spin test. Now, I also want to, the way our leader M is set up to run our game, we have to actually edit our bash RC real quick so that we can tell our leader M to run the default folder for our game here, which at the point of now is Tashio. So we want to run this other project called spin. So I'll change that and I'll source our .bash rc in our home directory, and then we can tmux attach, and I'll show you this new project. So it is currently just, actually, hold on, this is, we've got to kill this. Our tmux is actually connected to the old root, so we're going to do a tmux new session, call it spin. Okay. Now we're in our directory. So it's very simple. It's just a love.load. It's just a main.lua, and it's a love.load, and it is a love.update with delta time, and then a love.render. So it is, this is all of it. All we're doing is I was testing a bunch of different orbs, so I'll show you what this looks like, but let's run the game. So this is what this simple test is looking like. So I wanted to play around more with the, orbiting logic, because what we want to do is we don't want one fire circling us, we want 5. It could be 1, it could be 2, it could be 3, it could be 4, or it could be 5. I think that's kind of like once you become more proficient in spellcasting, you can cast more objects at once. So when you first start, it's just going to be one object kind of going around you. But I wanted to kind of visualize how we can add those other items. So let's see if we can get those other items working and what that might look like when we transfer it to our code. So one thing I did realize is that we need the it's like we need the value of our cosine and sine functions to be the same in order to have the equal amplitude for both the x and y. But we wanted to offset the orbs so that it's not just one orb circling us. So in order to offset that, I've been assigning these variables to just start at a different location. So let's say, like, if we wanted a second one, we would do math.pi divide by 4, and divide by 4 gets us exactly halfway across. We're updating it by delta time. We've got orb 2 updating by time 2 here. and then updating our player X position and Y position by our delta X for our character movement. And then we want to go ahead and render our orb 2, and let's see what that looks like. Okay, our player X is not noticed. How did we end up in Tashio? Okay. Main 78. Okay, I think we just need to initialize our player X and player Y as a... Oh. We somehow deleted this on accident. Okay, there we go. So here's our 2 orbs. So here's what happens if we don't change... If we don't change the value of our time, it'll just render the second orb. So the second, I mean, there are 2 orbs there. It's a red orb, then a green orb, and the green orb is right on top of it. So we need to divide it by 4 in order to get that offset directly across. So we need some kind of way to ask how many flames we want. And if it's just 1 flame, assign a certain value. If it's 2 flames, assign the correct 2 values, because the second orb isn't always going to be directly across. We might want it to be, if there's 3 orbs around us, we're going to want it to look like a equilateral triangle, right? So let's see what that would look like. Instead of time 2 being math pi divided by 4, I think we would want let's see. I think it's... Oh, and you know what? Yeah, let's... It needs to be, what, a smaller number, so... Let's see if... That looks about right. So it would be effectively like this, where we would say, okay, well, we get 1 unit. Math.pi divided by 6 is 1 unit of a third of a rotation. So that would mean that our third orb would get divided by 6, but multiplied by 2. So 2 units of a third spacing. And then we update over time. We're changing the amplitude the same every time, and the offset. So all we need to do is render our orb 3, and maybe it'll look like a triangle. Yeah. Okay. And then the way I set it up is like RGB. So red is 1, green is 2, blue is 3, and then we have some other ones, because ultimately we want... So like if you imagine the fire animated sprite replacing these orbs, then that is kind of what the game's going to be looking like. Our game had it spinning the opposite direction, but it doesn't really matter. We can maybe mess with that. Oh, Salto, yo, thanks for the Prime, homie. I appreciate that. That is really special, dude. I appreciate that. Yeah, we just had our first affiliate stream yesterday. We've been having a ton of fun. So we're trying to get the fire rendering around our character in a circle like this. But thanks, man. I appreciate it. Hey, look at you. Got that founder badge, dude. That's awesome. Yeah, you are our 3rd founder. So there's only 7 more of those puppies laying around. So how would we do if we want 4 flames around us? We would want to do instead of... I'm gonna comment these out for 3 orbs, just so we can kind of see a pattern, because we need to ultimately generate this dynamically in our game depending on how many flames we want around us. We want to assign the correct ratios to the orbs. So I think if there's 4 orbs, it would mean that it is a divided by 8. And I'll put the ×1 here, just it's not necessary, but yeah, that looks about a quarter. So if our step is math.pi over 8, then 1 is our flame count. So like we would cycle through our flame count. So our first flame gets ×1, second flame gets ×2, if that makes sense. And then we can ultimately like kind of map it out like that. So math.pi. Thank you, Salto. I appreciate you, man. You were the one that got me into streaming, to be honest. I mean, I was watching your stream. I think I just watched I think you posted on Instagram or something, a clip of it, because I didn't have Twitch or watch on Twitch, but I saw that you did that, and that gave me the idea to start recording my programming. And then I did that for about 300 episodes before I came here on Twitch. Okay. So that should be our 4 orbs. Now we need to render our 4th orb. Yes, check it. So that is the correct spacing for 4. Yeah, dude, absolutely. Yeah, I mean, I know we're both similar in the sense that we're not streaming us playing games. We're streaming our own art. So like I watched you and I was like, you know what? Like that's really interesting that I always had it in mind that Twitch was just streaming games. So seeing you kind of broadened my, you know, idea of what a streamer could be successful doing. Cool. Okay. So I think anything more than 5 is overkill, but we've got our 4 balls rendering pretty nicely. So it is going to be something like this, where we determine what the step is. So math pi divided by 8 is going to be the step for a quarter of a circle. Pi over 6 is our step for a third of a circle. Pi over 4 is our step for a half circle. And then it looks like we already did the math for our 5th circle, so let's go see what that would look like. So this is our 4 orbies. And yeah, I've got to stream a little earlier tonight because we've got friends coming over right at 7, and I normally stream at 7, so I'm just trying to stream before that happens to keep our streak going. Yeah, absolutely. Exactly. Yeah, I mean, I was never on Twitch, so I'd known about it, but I wasn't on there. I didn't have an account or anything, and then I saw you talking to your peeps while you were drawing and stuff, and I thought that was just so cool. Okay, so let's render our 5th orb and see if that stepping is looking correct. Yeah, exactly. And like I feel like I have a better focus if I'm doing something like pretending like I'm talking to somebody even. Like I used to stream to nobody. I would just record it, but I would pretend like I was explaining it to somebody, and it just helped me kind of stay accountable and more on track than I would be otherwise. So the fact that I'm literally talking to people now live is pretty crazy. Okay, so there's our 5 orbs. So this would be ultimately like the max spell casting we'd be able to get, because you get like a constant stream of collision detection for monsters we're trying to, forget what I call it, decorrupt. or purify, or whatever we call it. Yeah, we call it like a purification fire. And then the thing is, we want to figure a way. We want to be able to automate this so that we can just say, hey, we've got one flame, so just give us a certain variable for our cosine and sine. Flubba, it's always fun to teach someone something that you are passionate about. And hey, Super King, good to see you. You have a knack about talking about these concepts. Oh, that's cool. Because I mean, I'm very much a beginner, so I would watch my favorite programmer stream, and all of it is going over my head. So I thought that there was a niche for beginners who want to get into this kind of stuff to be able to kind of talk through it line by line and kind of show what we're doing. It's a lot more manageable when you can see someone who's not so professional at it just yet, because they can kind of talk to you at your level with it. So that's kind of my goal, is to kind of be able to talk about it and explain what I'm doing so that hopefully people can follow along. And even if you're not into Lua like Super King, that you would be able to at least kind of see what we're doing and get the ideas and then, follow the project. Hey, thank you for the bits, Salto. I really appreciate that. That is our second bit donation, and you made it rain. I appreciate that. That's awesome, dude. Thank you. I just ended up getting bits for the first time yesterday, and I already gave them all out. But I'm planning on getting some more. So we want to be able to control, like, we need a function to kind of automate this assignment based on the flame amount we want. So if we have a flame count of 5, we want to assign our numbers to be this. And we need to assign them to be these numbers if they need to be 4 orbs, and the constant in these is that our first orb will always get math.pi. So I'm thinking we might be able to come up with some function that is able to spit out, we ask what flame count we want, and then if it's a flame count of 5, assign it this number multiplied by the I, and then we would, since time 1 is always going to be math.pi, we only need to set it once. And then, so this is why even though times 1 looks weird, visualizing it with the times 1 there makes it easy for us to see that in our for loop, we're going to go through, so this is for 5 objects, so if it's 5 flames, we're going to generate 4 other than our default 1 flame. So our 5 flame function would be a for loop of 4, and it'll be I index 1, index 2, index 3, index 4, and then we multiply it by this constant for the other variables to get that equal spacing. So we also want to make this more readable, so it's like we're updating these values by the same amount, but they start off as a different amount. So that's what gets our offset there. If we didn't change what we initialized them to, they all would overwrite each other and we'd only see the last one we rendered. But we're wanting to, so this here is the amplitude. So like if we change this to a 5 on orb 1 is our red one, so we'll see that our red one is now, it's our speed. It's our speed at which we're rotating. So let's go ahead and change this for constant to become a variable that we can change for our speed. So we'll call it rotate speed up here. So we're trying to just make it look pretty. So we'll call it rotate speed, and we'll declare it once up here, and this is a 4. And we can put rotate speed all in here. I don't know of a way to replace it since we've got 4s everywhere. So we might just have to type it manually here. Oh my gosh, there's gotta be a better way. It's hard because like I would be able to find and replace the 4s, but there's all kinds of other 4s all around that, so I kind of have to do this jank stuff. But okay, so now it's clearer now that we've got a rotate speed we're multiplying by, and then this is going to be the amplitude. So if we were to change this to 300 that we're multiplying it by, our amplitude of our rotation is outwards, but it's keeping the same time that it's rotating. So that's useful to know, so that even though it's further away, it's circling at the same time, which is really cool. So that just means we can add more stuff. We can add, like, you know, our flames kind of come in and out of us as we spellcast if we want, kind of like swelling in and out like that if we wanted to. But what I think I want to do is let's call this 100. Instead of 100, we're going to call it amplitude. And then we're going to set our amplitude to 100 up here. Okay, so nothing has changed, but if we look at our code now, it looks a lot easier. So like if we didn't do this offset by player size 2, since Lua draws everything at the very top left as 0, it'll rotate around the top left of our square as the center. So what I'm doing is dividing it by 2, player size divided by 2, and we're increasing our x and our y by that, so that it is the center point of our player that we're actually rotating around. And we can do this, we can actually even do this, we can call this player offset and have it be equal to a player size divided by 2. Then we take every player size divided by 2 here, and we substitute player size divided by 2. Oh, I don't know how to put, we have to put an escape character here. What is the escape character? Because a / is actually what to replace it with in Vim, but I don't know how to do an escape character here. Do we do a... Huh, I'll have to look that up. I don't know how to do that, but go ahead. We call it player offset, right? Player offset. So ideally, by the end of today, we'll have a little function that can cycle through the number of flames we want and hopefully place them at the correct locations. So if there's 3, it's a triangle. If there's 4, it's a square. 2 is just they're on opposite sides. But this is so much easier to read now, because now we say like, oh, we've got a rotate speed, an amplitude, and then a player offset. And now that looks a lot less cryptic. As long as we gave ourselves the player offset, which we did, okay. So it should be the same, and it's still working. So what's cool about that is, like, if we want to change our speed and want it to be way slower, we just change it one time. Okay, well, so I guess, shoot, I thought this would keep the same spacing, but it looks like it doesn't. I didn't even see our first red dot there. So I think anything slower than, was it? That's weird. Okay, so Why is... Okay, see, so this is the stuff we need to fix. And it's easier... Prosto yesterday was saying that I should do this, build a smaller project with objects rotating so I can just practice and see how it works, which I think was a great idea. Because now we can kind of play around in this sandbox and get a game plan together before we're worried about all the state changes of our normal game. So... was this a 4? I guess, why does it work perfectly at 4 and not... We're changing every orb by the same constant, so why would some be slower? Oh, it has to do with the offset, I guess, up here. It doesn't make a lot of sense to me that changing a rotate speed here would change how they overlap with one another. So if we give this a smaller rotate speed, they'll be closer together. Except for the red one, which is a math.py. So maybe we just... I wonder if we give this, instead of math.py, we just give it a 1? If that makes a difference. Okay, I can't tell if it's right behind our green dot or not. Let's give it a 0.9 and see. Okay, I just don't see it now. Oh, it's there. The red is there, underneath there. Okay, so how would we do this if we want to be able to modify the speed for each one respective to our spacing? How would we do that? So it works perfectly for a speed of 4, and then I guess that means... And you know what? I never understood why if we wanted just 2 orbs, that the formula was math.py divided by 4. I wasn't understanding that, and I think it has to do with the speed that we're going. So where did our red orb go when we upped that speed? That is so weird that it would just disappear like that. It must be overlapping perfectly with another ball at speed 5. Yeah, it must be under one of those balls, because red is the first orb we render, so if any other orb is directly on top of it. And I wonder if we put like 4.8 in there, if we would see it very close. Yeah, we'd see it very close. So it looks like the blue ball's overriding it. Yeah. Okay, so we need to come up with a different way to do this. I'm kind of curious if we add another multiplier here. No, it's the same. The thing that is making them offset is that our time is assigned once up here to be these values. So it's like the speed, they're all rotating at the same rotate speed. It's just that the offset for the spacing of them is incorrect. So like if we do a slower rotation, we are in fact getting them all the same rotate speed, which is expected. It's just that the distance is jacked. So the distance that they are spaced, we're doing based on a certain amplitude, which we don't necessarily want to do. We want to be able to figure out what is the amplitude or what is the, I don't know what to call it, like the time offset, so that we render them in different locations. Because they're all being updated by the same value. It's just that they all start at a slightly different value. That's that little offset. So we need to come up with a way to be able to say, I don't know how to calculate what the offset is depending on the speed. I don't know what I don't know what that would mean. I guess let's set our speed to 1. And then we can normalize our formulas for a speed of 1, and then see what kind of patterns we might be able to see if we normalize to 1. So this, we do have rotate speed of 1 right now. So if we give our, yeah, we've got our first orb at math.pi. Okay, so let's take it one orb at a time here. Yeah, let's take it one orb at a time, and what we're gonna do is try to just get an orb on the other side of us. So we're gonna turn off these other orbs so we're not confused. It should be just our red orb and our green orb. And then that's not quite it. They should be directly across from one another. Which is what? Is that number even changing? Okay, it is changing. So that is too far. Well, let me see. Let's see what happens if we give it a slightly bigger positive number. I want to see which direction it moves it. So it moves it in front. If clockwise is going, if they're going in clockwise, then the green is a little bit in front now. So we want to see, we want a number that will turn this into whatever number is directly across from us. I know there's math to figure this out, but I really don't. I'm not very strong on trig here. So it looks like 2 pi is straight across, and that makes more sense to our unit circle here. Well, no, pi is straight across and 2 pi is all the way around. So it's still a little weird that timesing it by 2 would be halfway across. But that looks right. So I guess the question is, now that we've got 2 rotating at a speed of 1 directly opposite, if we change this speed, do they stay completely opposite one another? No, it looks like they're on top of one another. So, yeah, it's like... Why... This is very confusing to me. So we've got them here at a speed of 1, it's fine, but as soon as we scale up that speed, they overwrite each other. Or the green sits on top of the red at that point. So if we're multiplying the rotate speed by 2, let me just see what happens if we divide by 2. I'm literally just playing around and seeing what happens. We want to find the ratio that we can kind of... Gosh, I really don't know. Because whenever we change the speed, we have to incorporate our rotate speed into our timing somehow. So that when we scale it, it updates this according to our rotate speed. So like, let's see what happens if we just start out saying that this has to do with our rotate speed. And then we can find, well, let's see. See, we're giving them the same value here, so they should be overlapping, so just the green. So let's see if our second orb is getting pi over 2. See, and like, why doesn't that change it? It doesn't change. And then that isn't directly offset. Oh my goodness. Okay, so anytime it's... I think our adjustment here needs to be in between a value of 1. So, because anytime we like math.pi and math.pi times 2 is in the same spot. No, it's not. What? Okay. So let's see if we scale this now. If we scale the speed back down to 1, if it's still opposite. It is. Okay, so this is what we're looking for. Yeah, thanks, Saltamongo. I appreciate that, man. That is really cool. Thanks for the sub. Okay, so as long as we're modifying our time by our rotate speed, it'll scale here. So, if we wanted a crazy fast rotate speed of like 10, there's still, oh, see, it's not opposite of one another. 5 is fine. 6, what? Why would we only see it on odd numbers of speed? Anytime it's an even speed, it's gone. I'm not so sure. I mean, we're figuring something out. It's like, yeah, anytime our starting point is odd, they overlap. No, anytime they're even, it overlaps. How do we fix that so that we can give whatever number we want? Integer versus float division? I don't know. Because it's like... like... the fact that we're... like, I guess I don't know how many sig figs math.pi is in Lua, but yeah, I don't know. Hey, and Super King, thanks for all the gift subs yesterday. I appreciate that so much. I couldn't tell when it was happening that those were gift subs from you, so I didn't give you a proper shout out, but definitely thank you so much for all that. That made yesterday very special. So, did I call you Super Salad? I hope I didn't call you Super Salad. Super King. Yeah, I mean, I don't know. I'm new to this sine cosine stuff, so I'm not so like we could just make sure we make our rotate speed a multiple of, or make it an odd number. And it could be that we're doing some weird stuff too, like, well, see, look, okay. Yeah, whenever we give it, like, the closer and closer we get to an even number, well, yeah, the closer we get to that even number, we're starting to rotate, or starting to overlap each other. I'm sure this makes sense. I'm just not understanding it. It has to do with our cosine function in here. So like it loops since the sine and cosine is only between +1 and -1. Yeah, hey, thanks for stopping by and visiting. I appreciate it. That was fun. Hope you have some good dinner. Yeah, thanks. Yeah, we're doing a Harry Potter night, so we're gonna be watching Goblet of Fire. Which, yeah, I've got to stop this stream in 50 minutes, so hopefully we can figure something out. Okay, so as long as we're an even number here, so I guess what we can, or an odd number. So I guess what we can do is we can do, what's my fave of the movies? That's a tough question. I like, as far as books go, I love Goblet of Fire, and I love Half-Blood Prince. For some reason sticks in my brain as being like maybe my favorite book. But movies, I like Prisoner of Azkaban a lot, and I like Goblet of Fire's just got so much stuff happening in it. That might be my favorite. But I think I gotta go with the Sorcerer's Stone though for the movies. It's just like, if I only could watch one Harry Potter movie for the rest of my life, it'd be the first one. So probably the first one. But I love Goblet of Fire. I'm trying to think of a way what we can do to always get an odd number for the rotate speed, but like if we were to put, gosh, I don't know. I guess for now we'll just make sure we pass in an odd number for the rotate speed. And then we can scale it. So we can speed it up, and they maintain their distance. We'll have to test this for the other orbs to make sure that they maintain that same distance. But yeah, let's see if we can do. So if we wanted our third orb, what is the, okay, so we'll put that this is our 2 orbs. And then, so what's great about this is, like, this is a huge chunk of our game because it's going to be all of the spell casting, right? So like whether or not we have fire or ice or earth or water or whatever our elements turn out to be, it'll all use this same sort of rotate logic for our spell casting. So even though this might take us a couple episodes, it's going to be a big chunk of our game. So it's a pretty good bang for our buck in terms of what to focus on. So I'm curious what we have to do if we want 3 orbs now with this new logic. So like, I think we need to figure out what times our rotate speed in regards to pi is a step of a third. gosh. This is so, yeah, this has to do with the cosine and sine functions, because now if we give a odd number to our time 2, we get overlapped with our circle. So we need a way to, gosh, I wish I understood this better. I just not so strong on the sine and cosine functions. Like I know the ratios, I know the SOHCAHTOA, but I don't know, like school never taught me that that cosine and sine were a periodic function that just cycles between -1 and +1. Like I never understood that. And then now I know that's a fact, but I'm getting stumped on trying to modify it. Okay, let's slow this down so we can see it better. That looks like the 4th. So divide by 2 is the 4th, so is divide by 4, or no, divide by 3 to be our triangle offset. Where is our stuff? There we go. And see what's weird, if we give it an odd number there, it doesn't render, but if we give it an even number, it does. I don't know why it's thinking so hard every once in a while. Oh, that looks like a triangle. So maybe divide by 5. So we'll try giving our time 3 a rotate speed times math.pi divide by 5 times 2. We'll see. And then we want to render our third orb as well. Not quite. Yeah, not quite. If we divide by... Yeah, why can't we... So just dividing by 5 gets us most of the way. Let's see if we divide by 3 where that puts us. That puts us over our first orb. But okay. I really don't know what the hell I'm doing. Yeah, I've got to figure out a way to get the spacing of these right, because it's like, if I just pass in math.pi, like, I guess the first move we'd want to do, if we turn off our rendering for orb 3, we want to see the number that an equilateral triangle spacing would be if we offset this. So like if we, let's just say we offset this by a +1, that looks, is that perfectly opposite each other? If we do +2, see, okay, that makes no sense to me, but we want to figure out in a ratio what we need to add to be an equilateral triangle away, and I thought it would be dividing this. That looks like the 4th spot. So if we want it closer than that, 3 overlaps us with the red circle. That looks like, yeah, that looks like the triangle, but let's try this, divide by 4, and then multiplied by 2. And we're not rendering it. Let's go ahead and render our third Orby. Yeah. That's jacked. Okay, yeah. I have no idea. That's getting close, but we don't want to just be guessing random ass. Like, anytime this number is greater than 1, our cosine or sine function will loop it back to the other direction. So that's got to be why even numbers were giving it the overlapping behavior. But I'm not seeing how we can plug this in appropriately. So like pi divided by 4 so pi divided by 3 is closer. That looks like the triangle logic. So if we have we are rendering our third orb. So it's actually overlapping with our first orb here. Yeah, I really need to... Oh, wow. It looks like our Sekijo emote just got approved. Twitch just sent me a email. I don't see it here. I wonder if I can reuse it. Let's see. Check it out. Check it out. Check out that monkey booze. I was gonna name it Monkey Booze. But then I was like, I don't want to get in trouble for saying boobs. But check it out, we got Sekijo emote now. That's cool. So it sounds like my other ones are going to get updated here soon. So that'll be fun. Okay, so what I want to do is I want to just modify. It's like if we have our red orb as the default, this is how it's going to be spinning. And then we have a value that we're printing up so that we can see where that orb lands at what value we're printing up. So like we want to just modify this by, and you know what? Yeah, let's just divide this by 2. Let's see if that gives us, we've got that. Okay, well, I want to see the, yeah, I don't want to see the time 3, because that's just a number that's getting bigger and bigger and bigger, because all we're doing is updating it here. All of our time values are just getting bigger and bigger and bigger. We're just starting at a different location. So the question is, like, if we modify this by the smallest we can, just a 0.1, it's about that far. So I want to figure out what number that this becomes directly on the other side of us. Now, is it pi divided by 2? Because it's looking like it is, but that's not far enough. So is pi divided by 3 a slightly smaller number? I don't get it. I don't get it. So like if we just add 3, that's almost half. If we add 3.1415926, That's exactly on the other side of us. So pi is all the way around us, and 2 pi would be the whole direction. So our number of radians is all the way around. So how can we offset this? Maybe we can... Yeah. Maybe the secret is in the radians here. Like we can say angle gets math.radians of 90 degrees would be our 4. Okay, yeah, so let's see what 360 divided by 3 gives us 120. So 120 should be our triangle. Radians. Well, we're going to convert 120 into radians, store it in angle, and then we're going to modify this by our angle. So our... very confusing to me. Okay, well it looks like... Okay, so what if we do this, we multiply it by... I guess we have to do parentheses. So we would do pi over 2 first. Now that looks like the square. That looks like the triangle, but not quite. That's... Okay, well we're no longer not rendering it if we're at an even number. So the parentheses might have helped us out there. So if we want to get just the other side of us, it's not quite... What is the number for it? Really? Okay. I have no idea what I'm doing. Two pi is half. No, 2 pi is the whole unit circle, so I don't get why that does that. But if we were to times this by 3, then we're... See, that makes no sense to me. Okay, so anytime we have a pi amount added to our radians, it's half that circle. So if we want... Yeah, so if our whole thing, let's just do this different. We'll say, hey, we've got a whole circle worth of math.pi radians here. And then we want to divide this by 2, and maybe that... Okay. And then if we divide this by 3, it's still the same. Maybe not. Okay, that's looking right. Why did we get 3? Okay, we'll take out orb 3 here. I think we're making good progress here because this is actually making more sense now. Now that we're thinking in radians. So we're effectively multiplying our first one by a whole circle, which is unnecessary because that's just going to loop it back to its current state. But it's handy to kind of see the pattern, because if we modify each one by a math.pi times 2, then if we cut that in half, that will be exactly half of our circle. And if we cut it in fourths, it should be exactly a fourth of our circle. And then if we cut it by a fifth, it should be a fifth of our circle. Yes. Okay. Now I guess can we speed up by an even number now? And does it let us? It does. Okay, that is great. Okay, we're getting somewhere. We are getting somewhere, and we want to make sure if we're at a rotate speed of 1 and we want to cut, we want 1 to be completely opposite us, we divide by 2, and we've got it completely opposite. And if we want to speed it up, we can go ahead and speed it up, and the spacing is the same. They're still directly across from one another. So that is really good. So now I think now that we've got this concept, we need to make a for loop that goes through the amount of flame amounts we have, and it assigns the correct number, because it's actually pretty easy now, because if there's 2 flames, we want 2 spots for it. If there's 3 flames, we want 3 spots for it. So we just put in this. So we can divide by the flame count to get the correct spacing. This is really cool. Prosto would be proud. It took us a little while, but let's go ahead and do that. I guess the way to do this, so each of our orbs, I want to come up with a different name than time to put for each of our orbs, and we want to put these variables into a table, because we want to be able to pull it at an index. Right now they're in a variable that we have to call by name, but if instead we gave it a table, we can go ahead and update all the times in our table. So okay, so here's what we're going to do. We're going to say flame count. We've got a table called flame count. It's going to be empty for now. Now, instead of these times 1s and everything, we're going to populate the time based on the number of flame count. So we would loop through, and we would say for I gets 1, comma flame count. Now I think we can do something here. It's like for now, so if flame count isn't a table, but it's actually just a number, an integer of how many flames we want, and we say flame count is 3, then we're going to do something 3 times. And what we're going to do is table.insert, and we want to insert into our what do we want to call it? We want to call it orb speeds or something. It's like, it's going to be, hey, AKA Bob, good to see you. It's going good. We're, Prosto would be proud. We're actually making some good headway into getting our stuff rotating. So we've got it down to a point where I made this little project so we can kind of test it easier in a dedicated sandbox kind of idea. So like what we can do here is, if we know we have 2 flames, we can put 2 in here and it'll space them out evenly. So, and then not only that, we can also go update how fast we want it to be. So we can go say rotate speed is actually twice as fast, and it'll keep that same, and now it's jacked. Let's see. For whatever reason, sometimes when we put in an even value, it'll overwrite it. Our green dot's overwriting it, but when we put it in an odd value, it's fine. It has to do with our sine and cosine functions. But I thought we had fixed it just earlier, but maybe not. So right now we're trying to write a little function to populate. I don't like that we call this time, because like each orb is getting this variable called time and a number, and that we're updating it over time, and we're actually that's how we're getting the offset for our orbs. So like it's the same output over time, but it's a different starting point, different offset. So we're just trying to figure out how to populate these values based on the number of flame counts we have, rather than hard coding in these flame times. So we're almost there. I've got to leave here in 30 minutes, so I can't do much more, but we are going to try to get this to work. So let's say we had, instead of calling these time 1, 2, 3, what can we call them that make more sense? They're just like orb. It's like the orb offset. Orb offset, or we can call it just an orb table. Let's just call it an orb table for now. It doesn't really matter. So we'll assign ourselves a orb table. It is empty by default, but then we have a flame count of 3, so we're going to go table.insert, and we're going to insert the value. Oh, hey, Prosto, thanks for the raid, dude. I appreciate that. That's awesome. We're trying to, so I took you up on your advice to make a little sandbox of the rotating objects here, so I can play around and start to understand it. Yeah, hey Raiders, thanks for being here. We're making a little game. I can't show you just yet because we're in this other environment for our sandbox here, but we're trying to get our flame spell to be circling around us. So we're down to where we can kind of define this. Like if we have 3 flames, our second flame divided by, well, and this is of course busted now. Let's slow this down. Okay. So that looks like a 4 flame spread right there, because it looks like a perfect square. And then if we go, that doesn't look any different. So yeah, we're trying to just figure out how to be able to do, we want to be able to say, hey, if flame count is 3, then we're going to space them in a triangle while still rotating around us. And then if it's 4, it's going to be in a square around us. So we're trying to figure that out right now. And I thought we made some headway, but then this is starting to mess up now. So, and Prosto, we're doing like, so with the sine and cosine functions, whenever we pass like a multiple of pi, it'll overwrite, or I guess a 2 pi multiply. Well, I get confused because when we put in, I know the unit circle is the pi is all the way over, and then 2 pi is, yeah, I've got Discord here. I've got you know what, I forgot to make the Discord command on my did I not paste the Discord link in my command there? Let me go snag that for you. I'll add it to my Stream Deck too, so I can just kind of spit it out. Here we go. Share channel. Invite people. Here we go. I need to actually add the link to my Discord bot there, but... So yeah, you're saying math.pi times 2 divided by count is your step. That's what I was figuring out, like, because math... So pi times 2 is half, or is the whole circle, and then divided by 2 so that it would space it directly across, or divided by 3 so it would be a triangle. And that was working not too long ago, and then we just kind of messed that up. So like if we want... So that is right across from us, which looks right. Now if we go... See in this, whenever we change this to be an even number, it's overriding our other dot. Like our green dot overlaps. But if we divide this by 3 for the 3-step for the triangle, see, and then it's overlapping. It is overlapping. This wasn't always the case, though. I thought we had just fixed this. But I can't stay too much longer. I gotta head out here at in 20 minutes. But see, and I don't like that we're calling these time 1 through 4. I want to call it something else. So we're trying to populate these time offsets once we got our flame count. So that's what we were doing right when we got rated here. We're trying to insert into our orb table the correct time offset, which, like you said, is our rotate, or it's our pi times 2 divided by the count. But I'm not getting why this doesn't work anymore. So the even numbers are working, but the odd numbers overwrite. Well, no, 5 is looking right. So why is 3 not looking right? Looks like our player offset is off as well. Our player offset should be... Oh, well, why did that happen? Okay. Looking more right. That doesn't look like the triangle one, though. Yeah, So we've got a rotate. So what's weird is like our rotate speed here, when we're doing our cosine functions for each orb, we're multiplying it by that rotate speed, which is what I called that constant. And whenever this number is a even number instead of an odd, we get it overriding the other orb. So see, the green orb is overriding the red orb, which is right underneath it, when that is a multiple or an even number. So that I guess I don't get why that's happening. Like, I don't get why, because I thought that the sine and cosine is alternating between +1 and -1. But I don't get why you would overlap it like that. So if we give this rotate speed, like, I'm curious if we put like a 1.5 or something in there. Oh, see, yeah, and that changes the whole ratio of the spacing and everything. If they overlap, it's incorrect step. But it's the... Oh, yeah, okay, well, we are doing a... So when we change the rotate speed, we're scaling the... Well, let me see, time... Oh, we're multiplying rotate speed twice here. Our time should already have this. Well... No. No, this is just the starting point. Okay, so I think we don't want rotate speed as our starting point. We just want this. And then we do need this. Okay, so there's our 2. Let's see if that helps us out here. If we go to an even number here, they still overlap. So yeah, the step looks incorrect for 3 there. Let's see if we draw another... We draw another orb here. And we'll say that this is... If this one is the first one, this one's the second one, then I guess would we need to do parentheses? And then we need to render our other orb. Okay, well, so that was the correct step, it looks like, for 3. It's just that when we rotate by an even number... Oh, well... Is that working now? Okay. That's looking promising. Yeah. Yeah. Oh my god. Okay. That's actually pretty trippy. I like that. Okay. So, let's put like 5 here. See how fast that is. That's probably okay. Okay, so if we wanted 4, we would replace... We would have another orb here. This would be the 3rd step, and these would all be 4. So we're going to write a loop to kind of generate this for us. And as long as we're rendering this, we should have a square of items. Yes, perfect. And we can change that speed as we need. So that's looking good, and we have access to the amplitude. Yeah, what do you think of the double spikes back there? I thought the blue just blended in too much with everything else, so I thought I'd try to make it a little more eye-catching. Okay, I didn't see your... Oh, here. Draw orbiting circle times the step times the orbit. Okay, yeah. Yeah. It's just that from right now we've got... we do want to... We're using... Oh, God. Come on, dude. Let's get out of here. Get out of here. Get out of here. I don't like that we're using these time variables. We want to do this in our for loop with the flame count, right? So the flame count is here, 4 gets this, and then the actual step is how we're offsetting them. So we're gonna try to insert into our table, if we have, we're going to insert into our orb table the value of whatever this is going to be, which is going to be our function here, our math dot, and we need a step to count it with, math.pi times 2. Then we divide by our step, and then the offset is going to be our I here, but we need to start times 1 times 2. If our first orb needs no multiplier, just... Oh, and you know what? The time 1 is always going to be pi times 2, and time 1 is just our orb 1. So maybe we can start counting at the second orb. No. It's that we would want to... Our first step is a times 1, but that would be on the... My brain. Because yeah, if orb 1... Gosh, it's like orb 1 is its own thing. Because it's always going to be math.pi times 2. So it's like if we always have orb 1 as its own thing, then we can say any subsequent orb needs to go be generated through our flame count, and we could probably call it orb count to be consistent in this example. But then we want to put these values, these time 1, time 2, so it would be orb 2, orb 3, orb 4, multiplied by the I of our for loop there, and then we can go update all of our orbs with delta time, and then we can go ahead and update all our orbs with the correct value. So yeah, we want to... Ideally, we have this all so that, you know, if there's an orb count of 3, we generate... and I don't know... Yeah, I don't know if we want to do it. I guess we would want to kind of... If flame count is 3, or orb count is 3, we'd want to generate 3 orbs. The first orb has our math dot pi times 2, and then second one is divided by the step, and then times 1. Okay, so we're doing good. I've got to wrap it up here, so what we will do is comment out this table here. We will finalize this tomorrow. We've got it to a good point where if we want, let's say, for example, 5 orbs of fire around us, we know that all we'd have to do is give it a step of 5, increment each one by the step, or I guess if the times at the end here is the step, then the times 5 is like the slice of the circle we want to go into. And then if we render our 5th orb here, we should have 5 orbs. Well, okay, I don't know. I don't know why. What, our rotate speed is wrong? No. So 5 is fine there. 5 works there. I don't get why a speed of 5 is deleting them. What the heck? Okay, why is that the case? Why is a speed of 5 not rendering any but 1? Well, they could all have the same location. I don't know what's going on there. Why 5? Why? Because we're dividing by 5 here. So if our rotate speed is equal to our step, then we're rotating, then we're doing them all in the same spot, maybe? That's my only idea. Because we're... Yeah, because we're multiplying by rotate speed here, so if we're dividing it by 5 and then multiplying it by 5, they're all just 1, and then it turns off. So we have to make sure we don't have a rotate speed of... Yeah, because yeah, you're right, because we would be multiplying it by a different number anyway, so I have no idea why my 5 is just not working. It's rendering the yellow dot, which I think is the last one, so I'm kind of suspicious that all the dots are there, they're just all in the same spot. It's like if we give it... Okay, you see the other ones there, behind there? They're all like right there. That's weird. So yeah, we'll have to figure that out tomorrow. But yeah, I don't have this code posted to GitHub. I just made this today as like a sandbox. But it has been really helpful for me to wrap my head around how to do this, and we're making good progress. Show where you calculate the step. Well, we're not calculating step just yet. We're kind of manually putting it in right here. So the first orb gets pi times 2. Second orb is times 1. Oh, well, yeah, this, like, our first orb is just here, and then our second orb is divided by the step of 5, or I guess I don't know what we're making because I guess what we would want to do instead is include the step here as well, and then offset all these other ones so that they're like that. Let's see. Yeah, well, let's try speed of 6 here. Okay, so I don't get why 5 is The only thing I can think of is that it's this divide by 5 here. Because if we have like the squares there, 5 is fine, but if we go to a speed of 4, it has that same issue. So there's something. Yeah, I'll have to figure this out again, or figure this out for the first time. But I've got to head out. So where are you using time 1 and time 2? So we're updating all those variables by delta time, and then that is what our x and y of each orb is set to. That's the number we're feeding into our cosine and sine functions in order to offset them. It's incorrect. It's not time 1. Time offset 1. Yeah, but the you need to multiply time only. So you're saying take out the rotate speed from this cosine function. Only multiply time. So we only have one time, and then we have the time offsets. So, gosh, I've gotta stop streaming here. But so if we only have one time. So like there's time, we're updating that with delta time right here. It would just be time. And then we also need time offsets for these other orbs. And we would add that offset here in the cosine function, or we would add that offset in the function here, I guess. Yeah, I'm not exactly sure what to do with that. But this was the way I'm trying to wrap my head around it, because I've never done this stuff before. So I know this is disgusting, like just looking at that. Trying to figure it out. Yeah, I'll peep that formula. I didn't see, or I saw, yeah, let's see. Okay. So in your description, the I and the step that you're using and our orbit, so like the amplitude is what I'm calling your R orbit, but your I and your step come from where? So like I the amount of flame counts or orb counts we're doing, and the step is if we want it to be 4, or if we want it to be 2, or if we want it to be 5. Is step the amount that you're talking about, like that? Or is step the time offset to put them at the correct location that you're talking about? Okay, so step is the count. Okay. Yeah. Okay. So I've gotta stop streaming, unfortunately. We can't make a git commit today because, well, I mean, I guess we could add this as a git repo, but I don't really want to put that on my git repo because I actually just applied for a coding bootcamp that is going to be hopefully paid for by this program I've applied for. So I'm hoping I can maybe get into that. Okay, so yeah, time is just a variable. See, and I knew, like, whenever we would pass in time into our cosine here, I knew we needed to change that number in order to get a different output. So that's why I made these other time variables. So I know it's a mess. I'm sorry. I'm trying to be better. But thanks for watching, guys. I will go see if we can raid anybody. I know I've got a, Practical NPC is doing his, I think he's doing his Kickstarter thing. We can go raid him and say hi. I know he always appreciates when we raid him. But then I gotta get going. Thanks for watching, guys. I appreciate you, and I will catch you tomorrow.